Today, our guest is Eyal Amir, who is a founder and CEO of Ai Incube. Eyal is also professor at the University of Illinois Urbana-Champaign. Eyal is genuinely a pioneer in machine learning, and he has been contributing to the field way before it was a trendy thing. And his research lies in the intersection of machine learning and combinatorial algorithm. His PhD thesis was acknowledged as the best one in computer science department at Stanford University. And Eyal was included in top 10 AI professionals by IEEE. Eyal, thank you very much for joining our meetup and for your time, for giving this talk. So today Eyal will share about smart city concept. What are the major challenges in building smart cities, especially related to collecting data, and what kind of technology has been developed to address those challenges? So if you have questions for Eyal, please post them on chat, and Eyal will respond to them either during the talk or right after the talk. Eyal, thank you very much.
Thank you, Sophia. So I appreciate the introduction, and thanks for this opportunity to talk to everybody on a topic that I care a lot about smart cities. So everyone, so please feel free to ask questions in the chat. Of course, I will try to make sure that kind of from the corner of my eye I catch the question. Otherwise, I'll address it at the end. There's quite a few things that one can talk about smart cities. I assembled them into these 5 things. What is smart city at all? People talk about it for more than 10 years. What are the technologies being developed? What are the challenges? What resources you could use now, and what is coming in the near future? I tried to arrange the presentation according to these categories, but you will see, even though I tried to give every category some time, you will see that everything connects together. So it won't actually go according to the sequence. It will be a mix. So with that, I want to show you what Gartner says about what is smart cities. Gartner is a research organization, as you guys know, a research company, and they presented this slide on smart city, showing that smart cities is really the channel of information between smart buildings, smart educations, healthcare, public services, transportation and mobility, and smart utilities. That is a vision that a lot of us share. The idea of all of this information about the city flowing through some sort of a medium and everybody communicating, that's an idea that has been around for a while. The opportunities, I like this division also according to Gartner, which is opportunities in new cities or relatively new cities to be developed out of relatively small core. So those are what you would call greenfield. So if you have a new city that somebody builds in China, then or somebody builds in the US now as a result of moving, a lot would be easier to sell to and to create new solutions for it. From a business perspective, selling to an existing city is harder. So a city that is already fully built and some changes of the old infrastructure need to happen, that happens slower, with people finding it harder to move and put investments in. So in the presentation, by the way, you will see that I talk a lot about, I mix business and technology. Of course, I will from the nature of this meetup, I will talk more about the technology, but in my mind, technology and business really, they really come together and really need each other. And so they depend. The technological opportunities come from business issues, and the business opportunities come from technological abilities or issues. And so you will see that if I talk about business, it really also connects to the technology. So the cool thing and the interesting thing about this view of Gartner, this view is actually from 2010. So nothing new in that very high level view of smart cities. And one interesting thing that if you walk around the investment venture capital circles, then you would see that to a large degree, there was a lot of push of investments in this smart city for 6 years to 2016. And then some of the excitement died down. If you think about the hype curve of Gartner, then it kind of passed the height of the hype curve. But now I think a lot is happening that brings the big vision of smart city, brings it to real life. And it's not as a result of COVID, but it is accelerated by COVID. And I will mention in a bit in the next slide what it is. But we can all see that as a result of COVID-19, the commodities and logistics world has increased in importance. People have, Puvville movement has decreased and possibly will continue this lower version compared to previous times. Online bots have, of course, increased in importance, while the human customer care has decreased in importance. Again, it's anybody's guess if this is what would remain and what not, but the attention to health and safety, and the less attention to physical shopping, those are trends that are affecting us now. And one interesting thing that happened as a result of these together, that the data needs and the analytics needs have actually increased. Even though, let's say, people are moving from some cities, moving out of some cities, the data needs of those cities have increased, and also their analytics needs. And I'll show you why that is. So here's again a chart on the left that talks about the US. A different trend, of course, occurs in Europe. A different trend occurs in different countries in Asia, South America. But I'll focus here on the US because it's, at least to me, it's very clear to see what's happening. What you see is a trend in the pricing of rentals in different metropolitan areas and different cities. And the main point that becomes clear if you look at the details is that people are moving from big cities to small cities. So when people say, well, cities are going out of business, it's actually some cities that have very tight financials, and the other cities also have very tight financials, but for very different reasons. So if, let's say, 10% of San Francisco's population decide to move out, either to Texas, to Dallas, or to Sacramento, then those smaller or other cities, Sacramento, let's say, will have a problem because they will have 10% more trash. And that 10% more trash will cost the city money because the city pays dumpsters money for every ton of trash that people from the city dump. And while they charge us according to a trash bin, let's say, they get charged by the tons. So it's the same trash bins, but maybe they're more full than before, then the city's expenses will grow for Sacramento. They will have 10% more people. Over time, they'll have 10% more income because of taxes, but right up front, right immediately, they already have that expense. So that, of course, is a trend that we see across the US. In Europe, it's different. There is less movement. There is also slightly more opening, although just today they announced a lockdown for several major European countries, Germany and France included. But for us as technologists, that presents an interesting opportunity and challenge. The opportunity is to push to meet the demand of the accelerating demand for data in cities. I put here just a couple of examples of things that you probably don't see in major main media, or you don't notice, because a lot, especially around San Francisco, you hear the doom and gloom of some papers reporting that the city is going to go bankrupt and so forth. And so there's the perception that cities are running out of money. But the reality is that cities are investing a lot of money, and depending on, of course, the outcomes of the elections, the money will come in different ways to the cities. But it seems that, at least it seems to me, and it seems to some major analysts, that there is more demand for information, more demand for analytics, and that translates into real money that major cities, and when I'm talking about cities, not just cities, it's governments in multiple levels, that those cities receive and spend on the information that they need. So here are the kind of like at the high level, the 5 big opportunities. Again, I said I mix business and technology. These are the 5 big opportunities that I think exist today in information technology for cities. One is what we call curb management. So anything that has to do with the curb. So parking of cars, parking of electrical scooters, parking of different things that you would carry with you, charging stations, different categorizations of the curb, places that need repair, such as potholes, graffiti, real-time events that happen in the shops in the streets or in the hospitals that are part of the city. What happens to the inventory of the city? So the city actually has property on the street, such as benches. What happens to those inventory items? Also, what happens to the inventory behind the storefront? And finally, crime, security, health, the major part that affects our lives. So in each one of those, there's big need for information. I'll show you just one example. There are many, many examples, but take one example as an illustration. So typically, so city planners, with the help of external companies, they use information about inventory and utilization of trash bins to plan more or less trash bins in different places. So we're all familiar with overflowing trash bins. When something like this happens, trash in the street, that means that more, either you have more cleaning or less revenue, or you need to do some extra work on the city, or people just move out. So so you put too many trash bins, that means you spend too much money on their installation and maintenance. You put too few in an area and you get a problem like this. Another thing is that if you install the wrong kind of trash bins. So for example, if you have a trash bin that has recycling, but you didn't put the recycling in the right places, or you don't pick up that recycling and categorize it correctly, then again, it's an expense for the city. So by the way, these trash bins cost more than $1,000. It's not your little trash bin from Home Depot, because not only is it more sturdy, but the installation costs a fortune, more than $1,000 to install these things. So this is a real expense for every trash bin that the city installs. Here's another example. This is with regards to parking. You put too many parking lots, you will end up with empty parking lots that are underutilized substantially. You put too few of them, and you get people just circling the block. And again, you have problem with commerce. Too few cars can actually park. Fewer people come to the area, and they spend less money, and then the city makes less revenue from taxes. So what we, in a nutshell, the way that we as everybody that works in a smart city envisions the future is that there will be sensors that will provide that kind of information. So those sensors, for example, in trash bins that tell the city, tell the trash collectors, what is the status of those trash bins? There will be sensors in the street that will tell every driver where a parking spot is available in real time. There will be sensors in the street that will tell the city that there is graffiti on the wall, or a pothole, or the street is not clean, or there's a bad odor, or difficulty to walk or breathe, or some other disrepair or not uncleanliness of the street. All of those sensors, together with many others, will be connected to an internet of things, and that will flow into our everyday applications. The interesting part is that how. Well, first there's the question of when will all of those sensors be there, because trillions of sensors will require much more than trillions of dollars. So where will those sensors be? What will be the business model there? Who's paying and how? And what kind of information from those sensors will become available to all of us as consumers and enterprises and governments. So I'll put a kind of a snapshot of the world that I modified a little bit to show you what kind of companies and what types of kind of categorization. Again, this is categorization according to Crunchbase Insights. CB Insights, I'm sorry, not Crunchbase Insights, CB Insights. So you see companies that deal with parking, with energy grid, with urban planning, smarter transportation, connectivity. It's just one division of the world that you can look at. There are actually many, many others that are competing views of what happens to in this space. So maybe before, so this just I won't talk too much about it. I just want to tell you that at this point, I finished a very, very high level overview of what is smart city, and I will start talking about the details. So I'll start talking about the technologies being developed and challenged, and challenges that are involved in developing the technologies. And you will see that actually this topic will now consume everything else that I wanted to talk about in this presentation. So I'll switch into the next slide, and I will ask you in the meanwhile, so I'll pause for a minute, for half a minute, and see if anybody has any questions so far, things that you want us to discuss. Next thing is what is that future of, and how do we get there, and what are the opportunities that we all have here. And my co-founder Sergey Kozarenko, he says that the future is already here. So I think Sophia and Niraj should invite him, and he should give another talk that's much more technical than mine, but that's for another time.
Actually, there's a debate that is it possible that those sensors are owned not by government, but rather the citizens? And so basically people are debating on this topic. So what is your take on this?
My take is that in the future, it will, depending on what kind of economy we are. I think the more capitalistic countries, the sensors will be owned by somebody else, not the cities themselves. The cities are not, in my mind, best suited to monetize those sensors. So there will be investors who will invest in those sensors and then will monetize the data through marketplaces. So I'll forgive me. I'll pause while I'm reading the different comments. Right. So
about privacy concerns.
So there is another question about privacy concerns. There are different types of sensors. Some of them are much more privacy preserving. I'll talk about them. I'll show you a couple of examples. There are some that indeed have privacy concerns, especially cameras, but not only anything. If you have my colleagues in Google and Amazon and Apple will forgive me, but the devices that they present for home are a major security concern. But of course, they provide a lot of value. So a lot of the consumers, including myself, would buy them. And those privacy concerns are there. When we buy a camera that's connected to the internet for our home security and we put that camera in our living room, then clearly all of my video is traveling all across the world to the cloud service of the guys who sold me that camera. And along the way, everybody can see the video. And if it's encrypted, then only half of the people can see the video. And everything that happens in my living room becomes public information, even though really not by rights, but clearly there's a lot of security hazard there. So and privacy concerns galore. So there are privacy concerns. In Europe, it's much better regulated, in my opinion, than in the US and many other places. Europe is leading in that direction, in my opinion.
But does it prevent, like let's say those are more strict in Europe, does it prevent like expansion of innovation and, like of building those smart cities? Isn't it a kind of trade-off here?
Right. Absolutely. So, those who can experiment without any and can receive funding and can receive and can create business models without concern for regulation. Absolutely, it's easier on the innovation there. Is our quality of life better? Not sure. So it depends on what you prefer in your quality of life. Is the quality of my son's life better because now he has an iPad and he's connected to Roblox? I don't know. I think it's a little bit worse, but that's me as a parent. No. So, but yes, I do have strong opinions, of course, about this, with all the respect to the gaming industry. But same for security. I think that I'm in favor of regulation, but at the same time, you also need to compete with global forces, and so I think that there needs to be a very careful balance there.
So there's a question from Ravi: is a trillion of sensors the only future for smart city? Have you come across any other lines of thought for smart cities in your experience?
Yes, I mean we're and forgive me, I will mention, of course, my company Ai Incube. We believe that you don't need trillions of sensors to have a smart city. Um, of course, some sensors are very helpful, but you don't need trillions of them. And again, to just put this is, I'm telling you about my company, but of course it is following my point of view that with a few sensors, let's say 1% of the sensors of those trillion, you can get 80% of the value. So you need a lot of computation and a lot of technology behind those 1% of sensors, but then you really can get most of the value with 1% of the sensors. So you don't need maybe trillions of sensors, but some sensors are, of course, very helpful. Guys, so I do see some requests for the slides. I will send them after the presentation. So there is, so let's, I'll tell you kind of at the high level, and then I'll start showing examples of sensors and the different challenges and so forth. In general, what the cities need is both inventory information and real-time information about things like parking, I said, but not just parking, transit stops, bike lanes, anything that is part of the real estate. If you look at this as a real estate of the city, this picture, then the trees belong to the city. The city paid for them. The city is, of course, us. We are the citizens, the residents of the city. But by committee, the city hall represents us and owns all of this real estate that's in the city. Different cities regulate it differently. Some, for example, where my home back when I lived in Champaign, Illinois, the place, if there's a pothole in the street in front of my house, then I, as the landlord of the house, I am responsible for fixing that pothole, not the city. So that means that I have a lot of responsibility. The city is more, and in a sense, the city regulates, but I pay. In other cities, the city actually is responsible for what happens in the street, and the city owns and is responsible for fixing and doing things such as larger cities like San Francisco. Besides, so as part of that real estate, there is the inventory of the city, of course, also the inventory of the shops behind the city. There are lifestyle elements. All of those pieces of information are things that eventually us, as a community of developers, we would like to run a SQL query on this. So think about, imagine running a SQL query on the city where you just cross a number of live tables, let's call them, okay? So live table of street parking, and a live table of a garbage bin, and live table of potholes, okay? And so you would, let's say, as somebody that wants to go outside in San Francisco to a coffee place, I want a place where everybody wears masks and is socially distant, and I have a table available, and they have the bread that I like, and there is no smelly trash in the street nearby, and preferably no drug dealers. So I would like to run this kind of query and find those places and be able to go select the place that's closest to me, that also has a street parking available, and I get there and park. So those are the kinds of queries that we would like to answer, and there are different ways of answering them, and different data sources that would allow us to answer those. So here are some examples. The types of data that would be able to provide information for you about potholes. That kind of data comes from many sources. So telecom operators are a great example, as we all know. They have a lot of location information, but it's a rough location information, and they're highly regulated on what they can do with that information. There are insurance, car sharing, car manufacturers, and others that also provide real-time and historical information. And all of that information can then be fused in one way or another into an architecture that then analyzes the information and tells you an estimate if a pothole is there or not. So cars that drive in the streets, their sensors, their motion sensors can, by analyzing their motion sensors, you can detect that there is a pothole in the street. And when that information is communicated and aggregated and fused with other information, you can conclude with a high degree of certainty that there is a pothole in the street compared to what there was before. Using that information could then feed into the companies that are penalized when they're not fixing those potholes quickly enough. So no more need for a 311 call to inform the city that you have a pothole. The city immediately and how do you say, immediately and naturally knows that there is a pothole. So notice that my example with the cars does not involve installing a sensor in the street. So at a high level, this is kind of an architecture that one is a typical architecture that one could use. And forgive me, I took this from an old version of our architecture of ParkNav, that where we use data that is from ours and from partners of ours, such as Deutsche Telekom. And so forgive the logos on the left, but the main high-level architecture works with different sensors, different suppliers, and of course, different use cases. So at a high level, think about the whole thing going through calculation clusters that fuse the information. The information then gets sent to some caching platforms, and then when the need arises to the applications, they pull the information from that cache storage and use it in the different applications. So this is very, again, at a high level, the architecture that one could use to fuse that information. So I'll now jump into so I said this is the high level architecture. I'll go into the different types of sensors, very high level main, let's say 4 types of sensors that one sees in smart city. And they each have a very different way of being used and different challenges that come with them. So first and foremost, I think that's the most commonly referred to when one thinks about mobility data. Those are FCDs, or floating car data, floating person data, that really think about the phones and the cars and things that transmit location of people and devices. So today, every phone that's out there, besides maybe the most stupid phone, they have GPS processes that then transmit the GPS information to some cloud service that later uses that information, aggregates it, and delivers it to those services that may use it with our permission most of the time. The type of information, at the minimum, is the location. In the case of cell phone companies, the information many times can be also, it doesn't have to come from GPS units. It can come from triangulation and other technologies. But the positioning of that, what's called the localization, is a challenge. Even when you have a GPS chip or GPS special hardware, that localization is not precise. Increasingly it is. Nowadays there are very precise localization chips, but the localization software, but still this is not precise enough, let's say, for autonomous driving. But it is starting to be precise enough for very precise services that use that information. There is a challenge, so I'll talk a little bit about the localization shortly, but there is also a challenge in transmitting a lot of that information. So generating the information means that it consumes battery, and so a lot of those phones don't apply that GPS in real time all the time, because it consumes the battery, and what you end up getting as a company that processes the information, such as my company, for example, is that a lot of the supply of that information is actually not every second. It's not every split second. It's a lot of the information is every minute or 2 minutes or hour, or even longer than that, just because of a battery consumption situation. So you do have very heterogeneous types of this FCD data, and as a processor of that kind of information, you have to be able to treat the different information differently. You also need to remember that the sources of the information are very different. Some of the information comes from fleets of delivery trucks, and some of the information comes from taxis or Uber, and some of the information comes from just people walking in the streets and or attending shops. So there is a lot of that one should process. One should separate the data and not treat it as one piece of data. But that's on the processor side. Many times you don't know a lot. On the processor side, you many times don't know what are the sources. You don't know. Almost all the time it's aggregated in one shape or another, delayed in one way or another, so that privacy is maintained. Or you just you see a dot, but it's not related to the next dot. So you see that somebody was here at this time, but and another person was a few steps away, but you don't know, maybe it's the same person, maybe it's not the same person. So a lot of steps of anonymization are done between when the data is generated and when companies can process it. And that's a good thing, but also, of course, it creates problems for many applications. So you need to consider that when you create your application. Finally, I mean, it's a lot of data. If you're planning to store it, then create a big pocket, because it's expensive to store this amount of information. And of course, use it, retrieve it, analyze it, as all of you that use different versions of Hive or different technologies for storing and processing information, you would know. So here's an example of this is an old example of a localization routine. It's due to a friend of mine back when I was a postdoc at Berkeley. He created this illustration of a filter. What you see here is a version of what's called a particle filter. The particle filter localizes where in this case, it's actually not a particle filter. He would kill me for saying that. But it is a filter of a dynamic process where the dot, that moving pink dot that you can see, is just an example of a car or a person that senses all kinds of things around. The information that you use for that you get from the different sensory from the different sources that you have tells you where the trees are, or where some obstacles are, or where different things that the sensors notices, where they are with respect to a distance and maybe an angle. But all of this is imprecise and has to be fused. And so there's one of the oldest technologies from the 1960s called Kalman filter, that takes that information that is a Gaussian distribution, a multidimensional Gaussian distribution of the state space of where you are, together with a linear plus Gaussian noise transition matrix that then can be used to localize where you are and where are those things that are around you. So there is some mathematics, but at the end you get a provably correct and quite precise in practice procedure that tells you where you are, and correct that signal and the noisy signal that you got from the sensors. So this is, of course, used by many, and meaning that it is already used in a lot of the technologies that are out there. So you don't have to write it. A lot of this you can take off the shelf. The technologies of filtering, they are always being developed further and further. So combinations of particle filters and Kalman filters, sometimes called switching Kalman filters, or Rao-Blackwellized particle filters, and so forth. Those are technologies that are being used today in autonomous driving and in many others, and they can also help you localize the data that arrives from the different sensors that you have. What you end up creating, I said that one of the challenges is mapping from all of that information. So maps nowadays are becoming more and more precise, but they're not yet at 1 centimeter resolution precise. So you will see that for many applications, for navigation, you don't need 1 centimeter resolution. If all you're using is navigation on your phone, for example, it doesn't matter if you missed the turn by a couple of meters. But for, of course, navigation applications or planning inventory applications, you do need more precise localization. And so once you finish that localization, you need to match and position everything that you've sensed when you install sensors, you need to put them precisely on your map, or otherwise it will not fit with the rest of your sensors. So if I install a sensor in the ground, or I have a camera overlooking the street, and I then interpret what happens in that camera, combining that information with other information that arrives in, all need to have the same reference map eventually, so that I don't send a car, or I don't send a person into the wrong place. Okay, maybe I allow them to park where they're not allowed to park. So what we call in a high definition logical map, there is a maybe I'll take a step back. High definition maps typically refer to the three-dimensional information about what is and where are things at a very high degree of high resolution. So this centimeter of this cubic centimeter that is here, it is part of a tree. So being that piece of information that this is a tree, this little dot here almost is a tree, that is part of a high definition map. What we call high definition logical map is just the aggregation of those points into logical items. So things like driveway that don't have a physical, it's not like a tree, it's not like an item. It is aggregation of points that we ascribe some rules and meanings to, so that that's what we call the high definition logical map, and that's one of the things that you need to create and maintain for the different applications that you build with that sensory data that I mentioned. Okay, I'll show you one example. These are our colleagues from Deutsche Telekom. It's an interview that they did with one channel in Germany, where this is, and forgive this part of the video is about the Park and Joy application that they're running there, where you can pay for parking and also find parking at the same time. So you see that they drill in the ground a hole, and they put a sensor in that hole. So actually, I will once this scrolls a little bit, I'll point out that there are several challenges in installing those things. First, the sensor itself is expensive. So let's say, hundreds of euros. But even if the sensor was only €1, let's say the sensor was really the most inexpensive thing, then the installation is hundreds of euros. You need to send people in that street at the right time, where no cars will be parked, and some cities prefer not to block the street for your sensor installation. And so you need to figure out the right time and day to send the installation crew to specific streets. This installation crew is expensive. So this installing of one sensor is already an expensive proposition. So I'll scroll back just to kind of like here and stop here. So one thing that you also don't notice in many cities, maybe we forget in San Francisco that the sun is not always shining, unless you're in the sunset. But you forget that many times of the year, it's snowing. In that time, you cannot drill in the ground because the drilling actually uses water. And so that means that when you missed your window of opportunity, kind of between, let's say if I lived in Chicago, so it's really a short window of opportunity there, between like April and October, and that's it. If you didn't install the sensor then, wait for next year. So because you won't be able to drill in the ground anymore. Now, once you drill in the ground, of course, see, this is a very nice cobblestone there. You need to replace it with exactly that cobblestone that maybe, the guys who produced it Think about like, replacing something in your older Toyota. Toyota needs to keep those parts, and they cost money. So the parts are expensive once you need to replace. Same goes with those cobblestones. So you replace the cobblestone is now expensive. There's a lot. It sounds, I'm bringing all of this real world information to you guys to explain that installing sensors, even when they're not in the ground, even when you put it on the wall, somebody owns that wall. Somebody needs to maintain that wall, and installing it requires different permissions or different, and so while we are fast and furious startup guys, it does require a lot of communication with different other entities and permissions, of course, and maintenance. Installing one sensor might be easy. Installing thousands, millions is a very different ball game, and maintaining them, replacing their batteries, making sure that they communicate at the right speed, they don't run out of the battery, replacing the battery, so forth. And of course, making the whole thing is secure. Nobody stole your sensor, because just plucked them out of the ground and went away. But also security of the information that comes from the sensor. All of those are concerns. I will mention one interesting fact that, again, many people don't know. So I think it's it is well known that let's say the city of San Francisco is one of the more innovative cities. The city of San Francisco invested millions of dollars in parking sensors back about 10 years ago, together with Streetline, San Francisco Bay Area based company. So they installed the sensors, but then they found that really, it's great. There are a number of uses for the sensor information, but the batteries run out, they fail. The sensors are not as precise as you might think. Sensors in the lab, let's say, could be 95% precise, or even better, but in the street, in the real world, the sensors are not that precise. So all you need, if it's a magnetic sensor, then any truck or garbage bin or something like that will interfere with that magnet. If there's some sort of subway underneath, or anything could interfere. And that really brings the precision of those sensors, the magnetic sensors, infrared sensors, radar sensors, and camera sensors. They all have their imprecisions. And so in the real world, those sensors at best reach 95% precision. It just doesn't get easily much better than that. So what you think is a perfect sensor is actually not that perfect, even though you and I, we of course would like to think about sensor as something that's perfect. But imagine, the last time that, for those of you who've been in a parking garage and have there are parking sensors there that are infrared. So, and then you would notice every parking garage that has that, let's say there are 100 spots, 3 spots will have a faulty sensor. Why? Because of all kinds of reasons. But 3 sensors out of 100 doesn't seem like a lot. But when you then use it in an application to say, okay, you should go into that street and find parking there, there are 40 spots in the street. Chances are at least 1 or 2 of the sensors is faulty. So that means that as a driver, all of a sudden, going into that street when there's 1 spot, I don't know. Chances are maybe the sensor is wrong. You see? So 1 sensor out of 50 being wrong is already a problem. So, and this is 1 sensor out of 50 is 98% precise. And I said 95 is the right level. So at 95% precision, you really get the aggregation of those sensors becomes hard to really deliver the value to the end user. Maybe I'll stop here, see if there are questions, because I see from the corner of my eye there's a chatter. I'll examine the questions and I'll continue in a second.
Sergey is doing a great job. He's responded to.
He's answering for me. Excellent, excellent, very good.
But yeah, maybe we can start from the last question from Roxana. So coming back to the sensors everywhere, how is it to get into this business, especially in the US?
You mean, how do you get into the business of connecting to those sensors? So, or installing the sensors or selling sensors. So there are different businesses, but maybe, Sophia, maybe you have...
Roxana, you can unmute yourself and elaborate on this question if you wish.
Hey, hello everyone. So yeah, so there is a growing and dynamic community of ethics in AI, and it's really challenging the AI community on so many fronts. So my question is, how easy is to get into this business space, given that this community is not that it's gonna to stop, but it's gonna really continue to put a lot of pressure on how do we define privacy? What are actually the limits of privacy? Starting with our cell phones, how to use our cell phones, what kind of data we can record and make public, to these smart cities. So I'm trying to figure out how is the future going to look like, given the fact that AI wants to grow, but there are all sorts of pressures like this from other communities like ethics in AI. Thank you.
Yeah, so Roxana, you just so that you, Roxana, I'll just mention that Roxana is a professor of AI in University of Illinois in Urbana-Champaign, and specializing in natural language processing. So there is from what I can tell so far, the US is a little bit of a Wild West. It's more regulated than some other places, but of course less regulated than Europe. In Europe, it's relatively, well, depending on the country. Europe is of course not one country, and GDPR is interpreted differently in different countries. There are special legislations in different countries that explain GDPR in different ways. But to a large degree, even though there is a law, the law has not been litigated enough that the boundaries are clear cut. But there are high-level guidelines. So in Europe, the biggest guideline is if this does not help the user that contributes the data, then you need to be very careful with how you use the data and inform the user and let the user remove the data and not use the data otherwise. So that's at a very high level. In the US, the legislation, I know that California is advancing on that in that direction, but federally, the laws are still being created. As a business, what ends up when there's no legislation, the businesses create something, and then as the legislation appears, then the companies change what they're doing. But from a business perspective, let's say, when I create a company that, let's say, uses information from a sensor supplier, then my role, again, if there is no legislation, then my role is buying the information from the supplier, using it, and providing a product based on that information. if there is no legislation, then it's up to me and ethically and maybe the market forces to force me to not do very bad things with it. So if I sell a camera to someone and that person installs the camera in a sensitive area, and then I process the camera information, then it is my responsibility to my customers to treat that information reliably. But without any further guidelines or laws, I can do with the data whatever I want, of course. So ethics, in my opinion, will plug in eventually into laws. But depending on the society, it will, of course, get interpreted differently. Sorry, I said something very generic. I hope it answered and gave some guideline, some answer.
So there's a question from Sanjit. So you mentioned about investments that San Francisco did. So he asks if how hard or easy to justify these investments to the city.
So initially, that investment was that the city will be able to be more efficient in how it cites illegal parkers or parkers that are overstaying their time. So there will be a sensor in the ground that will notice that the car is still there, but the meter expired. And so they will send the enforcement to give you a ticket. So that was, of course, not a very popular use case. The drivers kind of like said, you're taking more money from us, and why are you ticketing us more and more and more? But from a kind of return on investment, it made a financial sense. From a political perspective, it's a different question, but from a purely ROI perspective, it made some sense. But turns out that the expenses were much higher than they seemed initially. So the maintenance of those sensors, not to mention, I mean, the error rate and so forth, created much higher expenses than it seemed before. And I never had a chance to ask the right person in the city of San Francisco about this, but it is my perception that it did not achieve that ROI that they were talking about. It gave some guidance to the enforcers, but not a lot. There are more technologies that are coming later nowadays into this space. So, for example, cars that automatically, so they drive around and photograph the license plate, and so it automatically detects that you overstayed, or it automatically detects that you did not pay and so forth, when, let's say, you pay with a mobile device. So when we pay for parking with, let's say, pay by phone in San Francisco, then there is a database of the license plates that have paid right now. This is crossed against the enforcer, and the enforcer then can indicate that the car is overstayed without paying. So there are, as I said, so now the sensor is not in the ground, it's in a moving car. And there is a different sensor that came from a mobile device that paid for that car. Okay, and so all of that gets fused in the cloud and instead of sensors in the ground. But that all, again, comes back to the localization that I mentioned. You know, if the car is parked in the wrong place, then you may not notice it, or you may not match it. You will think that maybe it moved. Maybe if there's a 2-hour maximum stay, but now you think that the car moved a couple of meters, then you will not cite it. So there are some technological challenges still, but yes, there are new sensors and new dynamics that are pushing this forward.
The question from, hello? Yeah.
Hello, this is Sangeet here. One more follow-up question. So for San Francisco, it's a highly populated city, a lot of people, a lot of traffic. So it may make that investment may make sense. What about like second or third grade cities where like or suburbias cities, like do such investments make sense for them yet, or we still have a way to go?
So there are different technologies specifically. And by the way, Sophia, I noticed that we're reaching the end of our presentation sometime soon, and I barely made a scratch of the surface. So tell me when you would like me to start wrapping up.
We don't have limitations. If people are engaged, if they have questions, and if you have energy to respond to their questions, I mean, we're totally fine.
No worries. So I'm following your guidance. So there is so Sanjeev, there are different technologies nowadays for enforcing, and so and for making efficient use of sensory information. And so one example, again, and forgive me for giving a plug for my company, but we're involved in some of this. So one example is installing only a handful of sensors in the city. In the city of Hamburg, our partners Deutsche Telekom installed thousands of sensors. But Hamburg is a very large city. Think about like 3 million people. And thousands of sensors is really a drop in the bucket. But those thousands of sensors are enough to provide the city with an analytic platform that we provide on top of it. There is, and it's enough information for the city to make most of the choices most of the benefits that it wants to get from those sensors. So if you copy this to a smaller city, then, a small city like the city of Pforzheim in Germany, there are 50 sensors, or order of that, between 50 and 100. And all of a sudden, 50 to 100 is not a big investment. And 50 to 100 and cover the main area of the city that they want to cover. And all of a sudden, it's a reasonable investment from the city's perspective.
Yeah, thank you.
Sure.
So, question from Eric: how important are payment systems for the IoT devices? Are blockchain-based payments considered?
So payment systems is some of the emerging best monetization for sensory data. So sensors, sensory data, and payment systems, I expect them to work very close together in the future. From what I can tell, there is use for blockchain, but it's just emerging. So it's not yet fully there. The challenges that companies in that area have, at least so far, are really contracting, because when you have let's say if I wanted today to create a payment solution for parking, let's say, then I would need to go to the city of San Francisco and ask them to accept my payment and to connect me to that database of theirs. Now, they right now have only one supplier. It's a kind of winner takes all. This is many of the cities in the US are like that. So it will require a lot of work on the side of the city to allow me to process, to provide payment to them. Why should they do that? I mean, of course, there are reasons for them to do that, but they will move slowly in executing this. So that's the bigger challenge before blockchain, but it might be that blockchain will bring faster movement in that area.
Yeah, I think we might wrap up, or you have...
I have a million other things, but I think I'll choose one thing to show you guys let's see, 1, 2, 3. There we go. I want to show you, this is a colleague of mine that runs a company. This is just one example. His company is called CityOS. It's just a vision. So, I mean, it's not just a vision, it's open code, it's open source. But you do see more companies that come with open source solutions for cities. And I believe that this kind of direction is a direction that could fit many people on this call today. Again, this is just one example. They have, they have this name CityOS. So if you go to cityos.io, they have some of this, but there are many, well, there are others like it that are trying to create open source so that the cities naturally can embed that in their operations. So that's also another piece of technology that's being developed. A lot of computer vision that I did not show you, a lot of other sensors that I did not show you from satellites and so forth. But I think we will wrap it up. It was a pleasure talking to you guys. If you have any more questions, of course, send them my way. It's an exciting area of work today, and I feel that we're just really at the beginning, but there are already real opportunities, and I believe many more companies and investments that will come very, very soon.